Okay, so this section's on inductive reasoning, conjectures, and counterexamples. Okay, we're going to go through problems 11 through 23. First thing I want to explain is what is inductive reasoning. Inductive reasoning is a rule or statement is true because a specific case is true. Okay? So, something that is true because a specific case is true. To give an example, what can I do to give an example? 2 times 3 is 6. 2 times 5 is 10. So I think that 2 times 6 will be 12. Okay? Because if I just take 2 of each, I'm just adding the 2. 2 times something is the same as adding the 2 numbers up. Okay? So that's inductive reasoning. A small little example of it. A conjecture is a statement you believe to be true due to the inductive reasoning. Okay? So conjectures is something you believe to be true. If I jump, then I will come down. If I jump up, then I will come down. It's reasonable to think that that's true, right? Why? What inductive reasoning lets you believe that that's true? Gravity, right? Okay. However, there's a counterexample, right? Is there ever a chance where that might not be true? If I jump up, I come down. If I jump up, I come down. Okay? Not necessarily always true. Okay? You could jump up onto something. You didn't come down. You jumped up on a log. You didn't come down. Right? So, a counterexample is an example that shows that it's not always true. Okay? So in geometry, this is going to happen a lot. Okay? Rarely outside of mathematics will you find a conjecture that's true all the time. Let me give you another example. I go to the store to buy a candy bar. I buy a candy bar and I spent my money. Okay? So, if I buy a candy bar, then I spend my money. Is that true? Sounds pretty true, doesn't it? Unless my mom gave me the money to buy her a candy bar. Right? Now, I spent my mom's money to buy the candy bar. Whether it was for me or for her, it doesn't matter. The point is, it wasn't my money. Does that make sense? So, even though the inductive reasoning shows that it was true, my counterexample showed that it's not true. Okay? And that's what we're doing. Okay? So, we're also going to be looking at patterns, right? So, if you look at number 11, it says, number 11 says it's 8 a.m. And then it is 11 a.m. And then it is 2 p.m. And they want to know what it will be next. What it will be next. 5 p.m. How'd you get 5 p.m.? Good. So plus 3, and you said, well, plus 3 will be 5. Yeah. Right? Good. How did they get 2 is plus 3? And so think of it also as 2 p.m. is also considered 1400 hours. Okay? So 11 plus 3 is 14. And 3 plus 14 is 17, and 1700 hours is 5 p.m. So, either way it can be looked at. The next problem is the number of non-overlapping segments formed by collinear points. Okay? Collinear points means they land on a line, right? So whenever you take something like this, they want to know, okay, I got 2 points. Okay? 2 points. How many segments do I have? How many segments in that point? Anyone? Someone? 1, 1. How many segments? Just 1. Right? What if I have 3 points? How many segments do I have in this one? 2? If I had 4 points, how many segments would I have? 4 points? How many segments? This is the problem. Yep. 4 points. How many segments? 3. Anybody see a pattern? If I had 5 points.
So every dot that's added, you'll take the last dot. So when you added 2 dots, or when the first dot added 3 dots, would be the second dot.
So every time I add a point, I'll have 1 less amount of segments.
Yeah.
So at 18 dots, I should have 17 segments. So at n dots, at n points, I should have 1 less than that. So I should have n minus 1 segments. Okay? And that's what they're looking for. Okay? 15. The number of... Oh, that was 15. Oh, we skipped 13. That was 15. We're going to flip these. So 13...
It's not like the writer does.
Yeah. 13 is actually this. They want to know what the next pattern is. So the first one's a triangle, the second one's a square, the third one's a pentagon. What's the fourth one? Anybody see a pattern? Huh? A rectangle? No. I could see that pattern though. Like some people saw, well, if it's this, then it's this, then it's this, right? And then it'll be that again. Some people saw it like that, right? I think what you're seeing is, hey, if it's that, then I could have another rectangle, and maybe it'll come up with something else that's pointy, right? But what are they trying to say here? They're trying to say is, how many sides does a triangle have?
3.
How many sides does...
4, 5, 6.
What is a 6-sided figure? A hexagon? A hexagon? Okay? Right? And so that's what they're looking for. Does that make sense? Okay? Next. 17. If, okay, this is where we're going to start using our symbols. if 1 minus y is greater than 0, then 0 is less than y and y is less than 1. 0 is less than y and y is less than 1. Alright, so right here you would try to find some things that are true. We need to find some things that are true for this. So if I plug in a 2, 1 minus 2 is how much? 1? Okay? No. 1 minus 2 is -1. Is -1 less than or greater than 0? No. So I can't use 2. I probably can't use 3. I probably can't use 4, right? Because they're just going to become more negative, right? So let's go down from 2 and let's use 1. Okay, so that one doesn't work. 1 minus 1 equals how much?
0.
Is 0 greater than 0?
No.
No. Can't use that one then. Can I use 0? 1 minus 0. What does that equal?
1.
1. Is that greater than... it is? Nice. 1 is greater than 0. Cool. So now let's use 0 over here. Okay? Now is 0 greater than 0?
No.
No. We just proved this with a counter example. This is not true. This is false due to a counter example. We took their hypothesis and disproved their conclusion. And that's what's coming up in the next section. We took their hypothesis, made it true, right? Made it true, but then proved that their conclusion is false. And that's what we'll be doing in this chapter. Proving conclusions are false or true. Okay? Next, we've got every pair of supplementary angles includes one obtuse angle. Okay? Every pair of supplementary angles includes one obtuse angle. This is number 19, okay? So, is that true? Every single one of these supplementary angles includes a obtuse angle. Is that true? No matter where I put this, obtuse, 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 no matter where it's at, where would it not be true? Give me a counter example. At what point would it not be obtuse?
At 90 degrees?
Yeah, exactly, Tim. At 90 degrees. Yeah, they've got two right angles. They're not obtuse. Okay? That's what it's looking for. Okay? So that's 2.1.